Our first topic, of course, is the pathophysiology of the illness. And so here is from, I believe it's MS, the MS organization posted this on YouTube. And I'm going to skip playing it now, but you can go follow my link, which I'll be sending you to this Prezi, and you can watch it in place.
Multiple
So here's
sclerosis,
just a video.
MS, is a disease.
The graphic from Lewis represents on top there, of course, the typical structure of a neuron with a long axon surrounded by myelin sheath, and then down below labeled B, C, and D are normal myelin sheath, and then in C, one that has been somewhat attacked by the disease, and then in D, pretty much full destruction of the neuron. Myelin itself can regenerate, which allows for remissions and relief from symptoms in an unpredictable and periodic way for most MS folks. In some cases, it's replaced by dysfunctional scar tissue. You'll remember we talked about hepatic sclerosis as another example of scar tissue rebuilding in a damaged organ and hampering its function. When just the myelin has been impacted, the nerve impulses slow down. Even with just myelin sheath involvement, you will get impairment of function because it is a slower signal than it would usually be. Once the axon itself is involved, you get total blockade and then permanent loss of function. Again, as we discussed in class, we now know scientifically that there is some reconstruction of neurons in the body, but it doesn't happen quickly enough, as far as we can tell, to help out in this disease. We think, as in many cases, this is triggered by a virus and that someone's genes make them susceptible to an over-response from the immune system, and in this case it crosses the blood-brain barrier into the central nervous system. The antigen-antibody reaction leads to the demyelination of the axons. The T cells seem to be the problem in this case.